today is proving triangles similar when you have just two angles, so we can use angle, angle. Remember, similar means they're the same shape, but different sizes. Okay? And in the last lesson, we learned that you had to have three sets of equal angles and three sets of proportional sides so that things would be similar. But now we're learning today that you only have to have two sets of angles. Okay? So two triangles are similar if they have two pairs of angles that are congruent to each other. Well, right now I have this one angle and this one. But now I need to see if I have another one. Well, what you need to do is you need to find the missing angle C or the missing angle D. Doesn't matter which one. I'm going to start off by finding angle C. Okay? Well, three angles add up to 180, so I'm going to do 32 plus 84, which is 116. And I'm going to do 180 minus 116, which is 64. So if you notice, 64 is the same as E. So I have two sets of equal angles, so that means they have to be similar. And you could verify this because 32 plus 64, that gives me 96, and 180 minus 96 is 84. So you get the same number again. So you no longer have to have all three equal, you just have to have two equal. Okay? So we just found that triangle ABC, doesn't matter the order, just as long as you keep the next one in the same place, is similar to triangle. A is the 32, so it has to be in the same place as F. B is the 84, so it's in the same place as D. And then C is in 64, so it's in the same place as E. So we find them similar by AA. This is a similarity statement. Similarity statement. So when it says to do that, that's what it's asking you to do. Okay? Now, you still have to be able to list the proportional sides. So it doesn't matter which one you do. I'm just going to start with triangle ABC. And so one of my sides is AB, which is this side. And the side in the same position is DF. So it's AB over DF. Now I pick another side from this shape, and I'm going to say BC. Well, BC is in the same place as DE. And then my last one, AC, is in the same place as FE. So those are proportional sides. The other thing we need to be able to do is find the scale factor. Now, depending on the order you want it to be, there's two scale factors. There's the scale factor of triangle ABC to triangle FDE, and there's the scale factor of triangle FDE to triangle ABC. They're basically the same thing, but one's going to be upside down compared to the other. Okay? So to find the scale factor, you look for a side in both triangles that has a number. Well, this triangle only has one number, it has the number 2. So I know that has to be part of the scale factor. And then the corresponding side to that is 7. So those two numbers I'm going to use for the scale factor. Okay? So the scale factor of ABC to FDE, you pick the number that has ABC first, that's on ABC. So this scale factor is going to be 7 over 2. When I want it to go the other way, I just flip the fraction. Now, if I asked you to find a side, let's say I asked you to find this side. We don't know what this is, so we'll call it X. I would still use my scale factor, and I'd still use this X. So X, same thing, place as X is 5. And now you have to decide which of these two scale factors you're going to use. Well, X is on the small shape, so I need to have the scale factor that has the small shape on top. So 2 over 7. So then we would solve, and I get X is equal to 10 over 7. So X is equal to 1 point something. I will just keep it as 10 over 7. I don't have a calculator. Okay. All right, so let's go to the side real quick. Now, what we're doing on the left side is there's certain types of angles you need to be aware of because not all the shapes are going to be basic like this, where it's two triangles. You're going to have to remember some of the relationships we learned in previous chapters. The first one comes from parallel lines and angles that are in the same position like this. And these are corresponding angles. So you have to recognize corresponding angles. Okay? Now, it's not going to look like this on the picture because it's not going to have the lines. This could be an example. You should recognize that this is the same as this when they're parallel. Okay? So they're not going to have all the extra lines, but you have to recognize, oh, those are parallel, they're in the same spot, so I know they're equal because of corresponding. Another type that you're going to have with parallel lines is alternate interior. If you see a pair of alternate interior angles on a picture, you have to say, oh, those are congruent because they're alternate interior. So this is what a triangle might look like for this. So if I know that this is parallel to this, then I know that this angle is equal to this one. Okay? And same thing here, this top one is equal to that one. So right there, if you have a picture like that, you know that they're already similar because you have two sets of equal side angles. Okay? Another common one, which people forget a lot of times, is vertical angles. Remember, vertical angles are equal. So I could have a little triangle up here and then a big one. If this is 30 and this is 30, I know those are equal, so then I know that those are similar. Let me zoom in for that. So these I would know were similar triangles because you have two angles. You got the 30s on each, and you got these vertical angles, so I know they're similar. The last kind of triangle that you have, or the last kind of thing you have, is when it's the same angle in both triangles. So let's say I have this big triangle, but then in here, I have it here too. Okay? It looks a lot like, oops, you can't see it. It looks a lot like the first picture, this one, where they're overlapping, because it's the same idea. What happens here is that this angle is in both triangles. It's in the small triangle, and it's in the big triangle. Okay? So when you have the same angle in two triangles, you have to recognize that it's equal. Okay? So these are the rules that will help you recognize things when the pictures are more complicated. Remember that you have to have two congruent angles to prove that triangles are similar now, instead of having to have all three angles in all three sets of proportional sides. If you have two sets of equal angles, then you know that the triangles are similar.